All right, let's talk about circles. For pretty much our whole lives, we've talked about them in degrees, right? 360 degrees, 90 degrees. But it turns out that's not the circle's native language. Today, we're going to learn how circles really think using something called radians. Let's get into it.
And you know what? Let's just start with the biggest reason you need to know this. This quote says it all. If you're heading towards calculus, this isn't just a suggestion, it's a hard rule. The formulas that make calculus, work, especially for things like sine and cosine, they only work if you're using radians. Trying to use degrees completely breaks the math. It's that important.
So what's the big deal with degrees anyway? Well, they're kind of made up, totally arbitrary. The whole 360 degrees thing was just a convenient number chosen by ancient Babylonians. It has nothing to do with the actual geometry of a circle itself. And because of that, when you get to calculus, using degrees forces you to stick all these messy, clunky numbers into your formulas. Radians are the clean, natural solution to that problem.
So what exactly is a radian? Honestly, it's beautifully simple. Picture this. You take the radius of a circle, that line from the center to the edge, and you curve it right along the circumference. The angle that little piece of arc makes from the center, that's 1 radian. It's an angle that is defined by the circle's own parts. It's natural, it makes sense, and it's why all the higher-level math flows so smoothly.
Okay, if you remember only one single thing from this entire explainer, make it this right here. This is your Rosetta Stone. It's the key that unlocks everything. A half circle is 180 degrees. We all know that. Well, that very same half circle is also pi radians. So 180 degrees equals pi radians. That simple fact is what you'll use for every single conversion.
All right, so we've covered the why. We get it, radians are important. Now let's get into the how. We're going to build your conversion toolkit so you can switch back and forth between degrees and radians without even breaking a sweat.
And here they are. These are the only 2 tools you need in your kit. To go from degrees over to radians, you just multiply by pi over 180, and to go from radians back to degrees, you flip it and multiply by 180 over pi. That's it. It's no different than converting feet to inches, you're just multiplying by the right factor to change the units.
Let's put this into practice. Let's say we want to convert 60 degrees into radians. Okay, so we take our 60 and we multiply it by our conversion factor, pi over 180. The best part is watching the units cancel out. The degrees in the 60 and the degrees in the 180 just go away. Then all you have to do is simplify the fraction 60 over 180. That reduces down to 1/3, leaving us with our answer, pi over 3 radians. Easy enough, right?
Now, let's try going the other way. We've got 5 pi over 4 radians, and we want to see what that is in degrees. So this time, we multiply by 180 over pi. And look what happens. The pi on the top of our number cancels out with the pi on the bottom of our factor. It's so satisfying. We're just left with some simple arithmetic. 5 times 180, all divided by 4, which gives us 225 degrees. See that pattern? It just works.
Now this brings us to the #1 rookie mistake, accidentally using the wrong fraction. We've all done it, but there's a super simple trick to never get it wrong again. Just remember, whatever unit you're trying to get rid of always goes on the bottom, in the denominator, of the fraction you're multiplying by. That way, it's guaranteed to cancel out. It's a lifesaver. Okay, so you're feeling good, you're converting things left and right, and then you see a problem that says, convert 2 radians to degrees, and you just kind of freeze for a second. You're thinking, wait a minute, where's the pi? It's a super common question, but don't worry, the answer is way simpler than you think.
Here's the secret. A radian doesn't have to have pi in it. A radian is just a number. So when a problem says 2 radians, it literally just means the number 2. You apply the exact same formula we just learned. We want to get rid of radians, so we multiply by 180 over pi. The setup is just 2 times 180 over pi. That's it.
You just run the calculation. You do 2 times 180, which is 360, and then you divide that by pi, about 3.14. And what you get is an answer of roughly 114.59 degrees. See? The process works perfectly whether pi is hanging around or not.
So we've nailed the why and the how. But you might still be thinking, okay, cool, but when am I actually going to use this? What's the real payoff? Well, it turns out radians are kind of the secret language running a lot of the technology you use every single day.
I mean, just look at this list. Computer graphics, physics simulations, processing audio and video signals, and this is a big one, video game engines. Think about your favorite game. Every single time a character turns, or a car drifts, or an object rotates in the world, game engines like Unity and Unreal are doing those calculations using radians. They have to.
If a programmer used degrees by accident, their character wouldn't just turn, they'd spin around like crazy. Radians are the language of rotation in the digital world.
So, at the end of the day, learning radians isn't just about getting a good grade in precalculus. It's about learning the fundamental language of how things turn and spin. It's the language that powers so much of our modern world. And that really leaves us with just one final question. Now that you can speak the circle's language, what are you going to build with it?